Hello, Assalamualaikum. My name is Nur Afika binti Ahmad Komari and I will present about first question, which is which popular DBMS products are based on the relational database model? The answer is the popular DBMS products are based on the relational database model are the following. The first one is Microsoft Access. The second one is SQL Server, MySQL, DB2 and Oracle. Okay, what is Microsoft Access? Microsoft Access is a database management system (DBMS) from Microsoft that combines the Relational Access Database Engine (ACE) with a graphical user interface and software development tools. It is a member of the Microsoft 365 suite of applications, including the Professional and Higher Edition or sold separately. Okay, we move to the second one, which is SQL Server. SQL Server is a relational database management system developed by Microsoft. As a database server, it is a software product with the primary function of storing and retrieving data as requested by other software applications, which may run either on the same computer or on another computer across a network, including the internet. Okay, the third one is MySQL. MySQL is a relational database organized data into one or more data tables in which data types may be related to each other. These relations help structure the data. SQL is a language programmers use to create, modify and extract data from the relational database as well as control user access to the database. The fourth one is DB2, which is a family of data management products, including database servers developed by IBM. They initially supported the relational model, but were extended to support object, relational features, and non-relational structures like JSON and XML. The brand name was originally styled as DB/2, then DB2 until 2017, and finally changed to its present form. The last one is Oracle, which is a database commonly used for running online transaction processing or LTP, data warehousing DW, and mix both of it or LTP and DW database workloads. Oracle database is available by several service providers on-prem, on cloud, or as hybrid cloud installation. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Akmal Yamintin Ali. My ID number is 62213 120219. My question is, which DBMS products are based on a logical model other than the relational data model? Before that, let me explain about logical data model. Logical data model is a data model for a particular problem related to a specific data management technology without being switched to a particular DBMS product is described the data as much as detail. A logical data model offers specific problem domain expressed independently of a particular database management product or storage technology physical data model, but in terms of data structure such as relational table and column, object-oriented classes for XML text.
Based on a question, a hybrid database is a type of real-time database system that uses both on disk and in-memory data storage by deciding which is most suitable for a given task. This type of database is beneficial when systems require reliable performance but is limited in size, and it increases reliability in case of an issue such as a power outage. The benefit of hybrid database such as performance, cost, and persistence. For performance, this is the in-memory part of the equation. Sorting, storage, and retrieving specific in-use data entirely from memory rather than from disk make all processes substantially quicker. Second, for cost, hard disk costs less than memory, so some of the money saved can be used to add more memory to improve performance.
For the last one is persistence. Because RAM chip cannot get close to the storage density of a hard drive, this are still used to store data needed for later use. This ensures that they are not lost in the event of a power outage. Next is object-oriented data model. For needs of object-oriented data model to represent the complex real-world problem, there was a need for a data model that is closely related to the real world. Object-oriented data model represent the real-world problem easily. Next, object-oriented data model. In object-oriented data model, data and their relationship are contained in a single structure, which is referred as object in this data model. In this, real-world problem are represented as object with different attributes. All objects have multiple relationships between them. There are 4 elements of object-oriented data model. First, object. Second, attribute and method. Third, class. And the last one is inheritance. For the object, the real-world entities and situations are represented as objects in the object-oriented database model. Second, attribute and method. Every object has certain characters. They are represented using attribute. The behavior of the object is represented using method. Third, class. Similar attribute and method are grouped together using a class. An object can be called as an instance of a class. The last one is inheritance. A new class can be derived from the original class. The derived class contains attribute and method of the original class as well as its own. So, the conclusion is hybrid and object-oriented data model are based on a logical model because object-oriented data model manipulate the data using database objects, which is more reliable than the relational data model.
Hi wabarakatuh. Okay, my name is Muhammad Sahil Akil. Today I will present about what are the relative strengths and weaknesses of the different types relational versus other logical models of DBMS. Okay, for the rational database system management, the strength is the first one, query flexibility. As long as your scheme is normalized, you do not have to know up front how you will query your data. You can always gather together the data you want using joins, views, filter, and index. Okay, for the second one is consistency via AC transaction. The relational database ensure that your commits are always atomic, consistent, isolated, and durable. If an error occurs, the whole transaction can be rolled back, restoring a consistent state. This is critical in some domains. Example, banking. Okay, besides transaction can also be coded into the application layer. If we think about transaction from a business's point of view, they have to be implemented in the application layer anyway, because they span more than just the act of saving data. However, keep in mind that long-running transactions are more likely to fail and can easily become a bottleneck. So, for the last strength for relational database management system is safety due to defined scheme and strict constraint checks. Your data have a fixed structure you can rely on. You cannot accidentally misspell a column name, submit a string instead of an integer, or enter a non-existing foreign key. The rational database will refuse the query and tell you this is very comfortable. However, the data validation and constraint checking can also be done in the application or user interface layer. Validating data only in the database is often too late. Usually, the user's input has to be checked at the upstream layer anyway. Moreover, complex businesses validation cannot be done by the database. Hence, it is questionable if a redundant check done by the database is really necessary. Okay, now we move on to the weaknesses of relational. Okay, now we move on to the weaknesses of relational database management system. Okay, for the first one is impedance mismatch between the object-oriented and the relational world. The application layer of an application is typically written in an object-oriented language. However, the object-oriented and the relational data model does not fit well together. In the object-oriented world, you have objects that are connected via references. They build an object hierarchy or graph. Contrarily, the relational model saves data in two-dimensional tables with rows for each entry and columns for the entry properties. If you want to store your object graph in a relational database, you have to slice and flatten your object graph until it splits into multiple normalized tables. Moreover, if you want to recover the objects, you have to join several tables, which can lead to complex queries and performance issues. Okay, the second weaknesses is weak distributed availability due to poor horizontal scalability. Okay, horizontal scaling does not work well with relational database. This is because of the strict consistency requirements. The mechanism for enforcing consistency, example locks and blocking approaches used for ACID transaction, are slowing down the performance if the database is distributed. For instance, each lock or primary key generation requires network communication and is affected by the network latency. This leads to long-running transactions and increased response times of the system. For the last weaknesses is performance hits. The drawback of decreased performance was already mentioned multiple times in the impedance mismatch and the weak distribution availability. If your schemes is normalized, you have to use multiple joins to put together the data you need. Joins are expensive. That's why it makes sense to denormalize the schemes in order to decrease the number of necessary joins, in turn improve the performance. However, this leads to redundancy and the danger of inconsistency, which must be handled in the application layer. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ihan Syami bin Cik Ghazali. So I will present about the others logical model. So the others logical model is a hierarchical database management system. So this system has many advantages. First of all is this advantage is data can be retrieved easily due to the explicit links present between the table structures. The second one is referential integrity is always maintain any changes made in the parent table automatically update in a child tables. The last advantage promotes data sharing. So I will present about the key measure of advantage in a hierarchical database. The hierarchical database is ease of use, the one-to-many organization of data makes traversing the database simple and fast, which is ideal for use cases such as website, drop-down menus or computer folders in system like Microsoft Windows OS. So due to the separation in system of the table from physical storage structure, this information can easily be added or deleted without affecting the integrity of the database. So, and most major programming language offer functionality for reading tree structure database. So the next is I will present about the advantage of the system. The first of this advantage is if the parent table and child table are unrelated, then adding a new entry in the child table is difficult. It is because of additional entry must be added in the parent table. The next one is complex relationship are not supported, and the last one is redundancy, which result in inaccurate information. So in this disadvantage, I will explain the measure of disadvantage in hierarchical database. So the major disadvantage is in this system, their inflexible nature. The one-to-many structure is not ideal for complex structure, as it cannot describe relationship in which each child node has multiple parent nodes. Also, the tree-like organization of data require top-to-bottom sequential searching, which is time-consuming and require repetitive storage of data in multiple different entities, which can be redundant. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Khairul Najmuddin, and I will present for the part of strength and the weakness of network database. So firstly, I will explain the definition of the network database. Okay, so firstly, database have a wide range of applications in business systems. They help automate repetitive document customization tasks. They enable telephone operators to get rapid access to customer details, and they speed up the consolidation of financial information. So database is categorized as the type of data and then establish relationships between those categories. The three main management systems for database are relational, hierarchical, and network. So each has its own merits. There are advantages and disadvantages to the network database model in comparison to other two data management systems. So for the next part, I will present about the strength and the weakness in details. So firstly, I will explain about the strength. So the main benefit of the network model is the many-to-many relationship. The hierarchical database does not account for many human organizational events that require an entity to have many upward links to other entities. For example, in a medical database, a doctor may be assigned to many wards and take many care of patients, while the patient is one ward that does not link through the relationship to the doctor entity, and so the patient entity also needs a link to both the doctor entity and the ward entity. So a series of cross relationships is quickly developed. So the next part is the weakness. Relational databases have structures that resolve many-to-many relationships between instances or records of an entity, but network database do not. For example, in the network database example, the patient may have many doctors and a doctor has many patients, but the network DBMS could only establish a one doctor to many patient relationship or one patient to many doctor relationships, not both. So that's all from me. Thank you.
Hello, Assalamualaikum. My name is Muhammad Fikri bin Hamdan. So I'll present about object-oriented database management system. I'll explain about the strength and the weakness. So for the strength, it allows users to define abstraction. OODBs have the ability to define new abstraction and to control the implementation of this abstraction. The new abstraction can match the data structures needed for intricate tasks, which is new abstract data types. That is, OODB packages today allow the user to create a new class with attributes and methods, have the classes inherit attributes and methods from superclass, create instance of the class each with a unique object identifier, retrieve the instance either individually or collectively, and load and run methods. OODMs also allow the definition of objects as aggregates of other objects, and aggregates can be nested at several levels. Properties too can have complex structures and can be defined using the by the collection constructor. Furthermore, they can have non-primitive objects as values, allowing deeply nested object structures. So next is it allows facilitate development of some relationship. So OODBs offer the feature of inverse relationship to express a mutual reference between two objects, which is called a binary relationship. So for the next strength is OODBs also facilitate development of some relationship. OODBs offer the feature of inverse relationship to express a mutual reference between two objects, which is called a binary relationship. This system ensures referential integrity by establishing corresponding reference as soon as a reference is created. It is even possible to automatically propagate deletion via this reference. Last strength for the OODBs is it eliminates needs for user-defined keys. The OODB model has an OID that is automatically generated by the system and that guarantees uniqueness to each object. This, in addition to eliminating the need for user-defined keys in the OODB model, has brought other advantages to OODBs. The OID cannot be modified by the application, as discussed, and in the notion of object identify provides a separate and consistent notion of identity, which is independent of how an object is accessed or modeled with descriptive data. Okay, so I'll continue to the weakness of the OODBs. So it is the first one is lack of query facilities. Most OODBs suffer from the lack of query facilities.
In those few systems that provide significant query facilities, the query language is not ANSI SQL compatible. The query facilities do not include nest sub-queries, set queries, aggregation functions, and group by or joins of multiple classes facilities fully support in the RDBs. So next one is no support for views in OODBs. OODBs do not support views. Although there have been several proposals, there is little agreement as to how a view mechanism should operate in OODBs. The development of an object-oriented view capability is complicated by such model features as object identity. What are the identities of the object in a view? On the other hand, there has also been an argument that data encapsulation and inheritance make explicit view definitions unnecessary. So for the last one is security concerns with OODBs. While RDBs support authorization, most OODBs do not support authorization. So RDBs allows users to grant and revoke privilege to read or change the definitions and tuples in relations and views. If OODBs are going to expand into more business-oriented fields, this feature has to be improved. Some OODBs require users to explicitly set and release logs. RDBs automatically set and release logs in user processing query and update statements. So that's all from me. Thank you.